In the antenna world, the terms radials and counterpoise are often used interchangeably because they both serve the exact same electrical purpose, providing a return path for RF currents in an unbalanced antenna. Just like a battery needs a negative terminal to complete a circuit, an unbalanced antenna like a vertical or an unfed half wave needs a second half to push against so it can radiate efficiently. The difference largely comes down to geometry and how they interact with the physical earth. Radial refers to a specific physical layout. Radials are wires that spread out symmetrically from the feed point, like the spokes of a wheel. They are almost always used with base-fed vertical antennas to create a ground plane. There are two main types of radials and they behave very differently. Ground mounted, buried or on the surface. Earth is lossy at HF frequencies. If you pump RF into a vertical without radials, a lot of your transmit power simply heats up the dirt. Ground radials provide a low resistance path for the RF to return to the feed point rather than getting absorbed by the soil. Because they are coupled to the earth, they are non-resonant. Having many shorter radials, example 30 to 60 wires, is vastly better than having a few quarter wave radials. Elevated radials. If you raise the base of your vertical a few feet in the air, the radials are decoupled from the earth. They act as a true isolated artificial ground plane. Because they are in the air, they are resonant and must be cut to exactly quarter wavelength for the band you are using. You usually need 2 to 4 of these per band. A counterpoise is any conductive mass used to substitute for an earth ground. Technically, a radial system is a type of counterpoise, but in everyday ham parlance, counterpoise usually implies a minimal non-symmetrical solution used when a full radial field isn't possible. If you throw a single wire on the ground beneath an unfed half-wave antenna or an inverted L, you are using a counterpoise. Geometry doesn't matter. A counterpoise can be a single wire dropping off a balcony, a chain link fence, the metal roof of a shed, or even the shield of your coaxial cable. Though using the coax often leads to nasty common mode current in your shack. Capacitive coupling. An elevated counterpoise acts like one plate of a large capacitor with the actual earth acting as the other plate. It creates a virtual ground point. Tuning. For high impedance antennas like an EF-HW, a short untuned counterpoise wire, often 0.05 lambda, is usually enough to balance the system. Here is a comparison at a glance. What it is. Radials, a specific geometric layout like spokes on a wheel. Counterpoise, the broader electrical concept, the other half of the antenna. Typical use, radials for quarter wave verticals, ground planes. Counterpoise for unfed antennas, random wires, elevated setups. Symmetry. Radials symmetrical to create an even radiation pattern. Counterpoise often asymmetrical, example a single wire. Earth connection. Radials often laid on or in the earth to mitigate soil losses. Counterpoise often isolated from the earth to provide a virtual ground. Ultimately, if you lay out 60 wires in a circle under your vertical, you have built a radial system. If you attach a single 15-foot wire to the ground lug of a 9:1 union, you are using a counterpoise.